In the first part of this talk, we explored what cross-plane providers are, as well as when it makes sense to create a provider, and how to actually create a provider. In this part of the talk, we're going to go through the process of actually defining a new managed resource for the provider in cluster. At a high level, the goal of the provider in cluster is to define resources in cluster that follow the same interface as other cross-plane providers, such as the provider AWS, GCP, and Azure. So the first part of creating a new managed resource is defining the API. We do this inside of the API's directory. More specifically, we're going to create a new folder for cache v1 alpha 1. Inside of this, we define a doc.go file, which contains the group name, which is cache.incluster.crossplane.io, as well as the version, which is v1 alpha 1. We're also going to scaffold out an empty resource for Redis, which contains a spec and status struct. At this point, this is all empty, but we're going to come back to this in a minute. Next up, we're going to define our register.go function, which defines all of our type metadata, and it also has an init function which registers this resource, our Redis resource, with the scheme builder. This allows us to run our code generation, which creates our deep copy, managed, and managed list full files. And so these are used internally by Kubernetes and Crossplane. When we run our code generation, it also creates our CRD for the Redis resource. At this point, there's something exciting here, but as we build this out slowly, this will get filled in with all of our different fields. Now, let's actually build our controller out a little bit. So at this point, our controller doesn't really have any logic yet, but we've set it up within this redis.go file, and we can see that we have a connector struct here, which describes how we connect to whatever API we're using. In our case, we're just connecting to the Kubernetes API server. And we also define our reconciler, which has all of our CRUD operations, such as observe, create, update, and delete. At this point, we can also add the controller to the setup function. And what this does is it sets up or creates all the controllers with the loggers and rate limiters when the pod is started for the in-cluster provider. Next, we can start to scaffold out the controller. So before you actually write your logic, it's important to define the different functions that your client needs to have. And so in our case, our client will have a creator update function, as well as parse input secret, and two functions for deleting the deployment and Redis service. At this point, these methods aren't defined yet, but as we build this out, we'll slowly see that things come together. We're also going to define 4 functions here for creating our Kubernetes resources for our Redis deployment, containers, as well as the service itself. So now we can head back to the API, and we can see that we've added a few new fields here. So at this point, for simplicity's sake, we have 3 fields, namely password secret ref, config variables, and memory limit. Memory limit states the maximum amount of memory that we want to make available to the Redis pod in our deployment. Config variable allows the users to inject arbitrary environment variables into the Redis instance. And lastly, password secret ref references the secret, which will contain the password for our Redis instance. If no reference is given here, then we will expose Redis without a password. Once we define these attributes, we're going to run our code generation again, and this will update deep copy as well as our CRD. Now we can actually start the process of implementing our client. So here, we define parse input secret as a function which gets our secret and then extracts the password data from it. Delete Redis deployment just validates that the deployment exists and then it deletes it. The same thing happens for our delete Redis service function. Next up, inside our make Redis deployment, we define our apps v1 deployment resource, which contains the object meta and spec for our deployment. the containers are defined in another function down below, which first sets up all of our environment variables, as well as our memory limit. And then we define the pod as having a container which contains the Bitnami Redis image, as well as which exposes the default Redis port 6379 with the maximum memory and environment variables. We also have a liveliness probe to validate when the pod or container is actually started. With our client defined, we can actually start the process of now building out the controller itself. And so here we can see that we've defined our connector function as extracting the provider config reference, getting the kube config from there, and creating a new client with that specific kube config. Our reconciler then has a reference to the Redis client, and it's responsible for observing the current state of our managed resource. So namely, we check if the deployment exists, if the deployment is ready, if it's currently in the progress of scaling up, and we also validate if the service exists. And if any of these resources don't exist, the controller will fail, and it'll get put back in the retry loop for our reconciler. If everything exists and it looks good, we'll return successfully that the resource exists and it's up to date. We'll also expose the IP address of Redis at a specific key in our secret, namely the endpoint key. The create function actually runs the process of creating our Redis instance. So this means deploying the deployment and service resources. At the end, once everything is created, in our secret, we will expose the port and password. So in our case, the port is always 6379, and the password depends on the input secret if it exists. Update in the Redis resource at this point is a no-op, and delete simply just deletes the deployment and the service. So with that, our managed resource is implemented, and we can define some examples in the examples cache folder. And so this will have our sample Redis resource with the password reference as well as our provider config. So just like that, it was that easy to create a managed resource. All in all, this process took me about an hour or less than an hour. And we have a V1 Alpha 1 release of Redis in cluster. So we can add some additional features. There's still quite a bit of work to do, such as a Redis cluster or additional testing for Redis, because at this point we haven't written any tests. But we have enough now where somebody can, provision Redis in cluster using this provider.